I have in front of me here the handout that says Lesson 2-04 in front of it. You should not watch any more of this video until you have either gone on my webpage or gone to the email you received from me today and printed out this document in addition to the homework. This is the single page that says Lesson 204 on it. Pause this video right now and go print it out if you don't have it with you. Alright, assuming that you have this lesson 2-04 in front of you. Again, you really want it in front of you because this video quality is not great. I'm hoping to make better videos in the future, but you can't read very well what's on this page on the video here. You can read it a lot better if it's in the screen in front of you. So we're going to start looking at this problem here, which is numbered 2. It really should be numbered 3, and that should be numbered 4. I misnumbered these. And this problem says a line segment has endpoints at 1, 8 and 7, 2, and it asks what are the coordinates of the midpoint of this segment. You have done many problems like this. In fact, many were assigned like this on Friday's homework. You've already done a lot of problems like this. What's the difference between how this problem is being presented to you on this page and how it was presented to you on Friday? The difference is I didn't give you a grid. So how are you going to solve this problem? Well, you might give yourself a grid. Why not? You want to get a problem like this right on a quiz? Invest the time in creating a grid for yourself. 0, 4, 8. I'll divide that into 2, 1, and 3. There's 1, 2, 3. Here's 6, and 5, and 8. 5, 6, 7, 8. And then here's 4 going up, and another 4 going up. So that's 4 and 8. And here's 2 and 3 and 1, 1, 2, 3, and here's 6, and then here's 7, and here's 5. And then plot the points. 1, 8 is where one endpoint is, 7, 2 is where the other endpoint is, and then do this problem just like you did on Friday. From here to there, we want to find the midpoint. Count how far it is. 1, 2, 3, 4, 5, 6 down, and 1, 2, 3, 4, 5, 6 to the right. So instead of going 6 down and 6 to the right, we'll only go halfway. 3 down and 3 to the right. 1, 2, 3, 1, 2, 3. There is the midpoint at 4, 5. I can read it very clearly off of my grid that I created. Give yourself a grid, makes a problem like this exactly like the ones you did on Friday. Also for number 4, now that we've got a grid, we can use it for this problem as well. A line segment has one endpoint at 4, 7. There's one endpoint. I'm going to put a big E there for endpoint. And it has a midpoint at 7, 5. I'm going to put a big M there for midpoint. So if we're asking what are the coordinates of the other endpoint of this segment, well, here's one endpoint, here's one midpoint. We've got to go past that midpoint to find the other endpoint. How far? Well, to get from this endpoint to this midpoint is down 2 and 3 to the right, so we've got to go down another 2 and another 1, 2, 3 to the right. That takes me off of my grid a little bit, but hey, I don't really need to draw more lines in here to realize I've gone from 8 to 9 to 10. So the coordinates of this point are 10, 3, it looks like. There's the other endpoint. Make a grid. Okay, makes problems like this fairly easy. Now, there are ways to solve both of these problems without drawing a grid for yourself, and we talked about these in class today. I'm going to go over them very quickly, but they can be very confusing because there's some adding, subtracting, some dividing going on, and students tend to confuse, what do I do when? Wait, am I supposed to add now, subtract? Do I add, then divide, then subtract? If you don't understand these methods, give yourself the grid, because I think everybody understands how to do it that way. But here's a way to do it without the grid. If you're looking for a midpoint, a point exactly in the middle of two others, that's like finding the average of two quiz grades. If you have a 50% quiz grade and a 60% quiz grade, the average is the value right exactly in the middle. And how do you find the average of two numbers? You add them up and you divide by 2. That would get you the average. So if I want to find the point which is exactly halfway between these two, right exactly in the middle, I can average the two x values, 1 plus 7 over 2. That will get me the x coordinate of the midpoint, and then average the two y values, 8 plus 2 over 2. That becomes 8 over 2, which is 4. That's what we got from the grid. And this becomes 10 divided by 2 is 5. And that's what we got from the grid. It's fairly simple. And I like this averaging method because you can use it even if the numbers are very large, very far apart, even if they're negatives. It doesn't matter. This averaging method works quickly, easily, and reliably if you remember when to use it. You can't use that averaging method for this problem. Well, you could, but it would be way more complicated. Here's what you could do for this problem. It's different from averaging. And then a lot of people confuse what to do for this problem with what to do for this problem. They don't remember when to average and when not. So I'm not recommending this approach, but I will show it to you. We talked about it in class today. Look, if you're going from one endpoint to the midpoint, and the x values are going from 4 to 7, that's 3 steps up to go from an endpoint to the midpoint. So to get from this midpoint to the next endpoint, you're going to have to go another 3 steps up from 7. So 3 steps up from 7 would be 10. That's the x-coordinate of the other midpoint. Now look at the y values. From 7 to 5, that is 2 steps down. 7 to 5 is going down. So to get the y-coordinate of the other endpoint, you have to continue to go down the same number of steps. 2 steps down from 5 would be 3. And here's the answer that we got when we did it on the grid just a couple of minutes ago. Okay? A lot of people confuse these two approaches to these two problems. They forget when to average. There's actually some subtracting going on. You may realize, how do we get from 4 to 7? How many steps is that? Well, you get that by subtracting 7 minus 4. And then you get 3, but then you add that 3 to the 7 to get 10 because we're going up. And the adding, the subtracting, the adding, the dividing, it all becomes very confusing to some people. Maybe you should just grid it out. Let's go to the problems at the top of the page. A is halfway from T to J. By that, what I mean is, and some people had a question about that in class today, is I mean halfway on a straight line from T to J. Not halfway around this path or halfway around this path, but halfway on a straight path, unbending, unturning from T to J. So where is that point A? Well, it's somewhere around there. And then the question is, how do you get from B, which is here, to A over there? And what I'm looking for here, and this wasn't clear in class today either, but I made sure everyone understood. So I'm looking for how do you get from B to A in terms of north, south, east, and west. How many miles north or south or east or west do we have to go to get from B to A? Well, it's really going to help if we can find A more precisely. And the only way that I'm going to recommend you do that is with a grid. This problem comes with no grid either, but make one. Look. From L to V, it says, is 6 miles. So split that up. That far is 3 miles, and that far is 3 miles. And then split up the 3 miles into 1, 2, 3, and split up these 3 into 4, 5, 6. We're starting to make a grid here. If this whole thing is 10 miles, and this much is 6, then there must be 4 miles remaining over here. So I'm going to divide that up into 2 and then 1, 2, 3, 4 like that. Looks like my point A is going to be 8 miles to the east of B, it looks like, but we'll confirm that a little bit later. Now the grid going up, this is 2 miles, so let's split that into 1, 2. And here's another 6 miles up here. So let's split that into 3 miles here, and then 1, 2, and then 1, 2, 3 up there. All right, now I'm not so sure exactly where that point is. But let's see. If it is halfway from T to J, and from T to J is 2, 3, 4 steps to the right, and then 1, 2, 3, 4, 5, 6, 7, 8 steps down, I want to go 2 steps to the right and 4 steps down. So 1, 2, 1, 2, 3, 4. Right there. See, the grid really helps us to be precise. That's where point A is. And now how do I get from B to A? Well, just let's count our way. 1, 2, 3, 4, 5, 6, 7, 8 miles to the east. And then from there, 1, 2, 3, 4 miles to the north. You could go 4 miles north first, and then 8 miles to the east. I don't care what order these two instructions come in. But it has to be the right number and the right direction each time. And number 2 is just like it. C is halfway from K to L, from K to L. Uh-oh. Looks like I might need to extend my grid up into this open space here. So I'll do that. And then I can count my way very carefully halfway from K to L. From K to L is going to be 10 miles to the left, 10 left, and then 1, 2, 3, 4, 5, 6 down, 6 down. I only want to go halfway. So 5 to the left and 3 down. 1, 2, 3, 4, 5, and 1, 2, 3 down, right where that M is in the word miles. That's where my point C is. And now, how do I get from J to C? Where's J? Where's J? J's down here. From J to C, 1, 2, 3, 4, 5 miles north, 1, 2, 3, 4, 5 miles west. 5 miles north, 5 miles west, and we're done. All of the homework tonight is a whole lot of problems like these. The grids make things easy. I strongly recommend them. We have a quiz coming on Thursday that we will review for in class tomorrow. Now, if you haven't printed out that homework already, but you should have printed out along with this, go get that homework. And if you need to review this video, review it. Repeat it. Rewind it. Review it. And it should help you do the homework tonight. We'll see you tomorrow.